Hello students, our today's reaction is Friedel craft acetylation. Friedel craft acetylation or acylation. See, again this reaction is an example of electrophilic substitution reaction. Here what happens? Benzene or any other alkenes, when they react with acid chloride or anhydride, like I'm taking here acetyl chloride or acetic anhydride can also be taken. Or this one is benzoyl chloride. So when benzene or any other alkene are treated with acid chloride or acid anhydride in presence of anhydrous AlCl3, see what happens? Um, we obtains the aromatic ketone. See what happens here? The reaction is example of the electrophilic substitution reaction. Here carbonyl carbons and chlorine bond breaking occurs, and thus now the acetyl group replaces the hydrogen from the ring, and we obtains here acetophenone, and the Cl minus sets free along with the hydrogen which is replaced from the ring, and we obtains aromatic ketone, that is acetophenone. Similarly here this carbon oxygen bond breaking occurs, and now this acetyl group will replace the hydrogen from the ring, and we obtains acetophenone, and the hydrogen which is replaced from the ring combines to the CH3COO and sets free as CH3COOH. Similarly in this case, if benzoyl chloride is taken, this bond breaking occurs, and the hydrogen will be replaced, and we will get a aromatic ketone, and the hydrogen which sets free from the ring combines to the Cl and forms HCl. So this is the Friedel craft acetylation. So in this way we may write the reaction. See, remember in Friedel craft acetylation or acylation, what happens? Benzene or other alkenes reacts with acid chloride or acid anhydride in presence of anhydrous AlCl3. So we obtains the aromatic ketones. Okay. Now we'll discuss the mechanism of the reaction, how the reaction occurs. See, let this one is an acid chloride, and this reacts with a catalyst AlCl3 and hydrous. See, the reaction is example of electrophilic substitution reaction, and that's why the reaction occurs in 3 steps. In step 1, here this involves generation of electrophile. See what happens here in anhydrous AlCl3, the aluminium is having 6 valency electrons, means there's the deficiency of 2 electrons. So in order to compensate the deficiency of the aluminium, see here the carbon chlorine bond breaking occurs, the Cl sets free from here as Cl minus and combines to the AlCl3. And we got AlCl4 minus. And now see here the carbon has lost its electron, so we'll get the carbon will become positively charged, and in this way we'll get electrophile is formed. Now in the second step, this electrophile will attack the ring. See, this one is acetylation ion is obtained, which acts as an electrophile. Now in the second step, this electrophile which is obtained in the first step, this electrophile attacks over ring. See what happens here. Actually, there's in benzene ring there is a cloud of electron cloud above and below the plane of the ring, and now this electron deficient species approaches the ring, and now by making the use of the 2 electrons from the cloud, the ring forms bond with the this electrophile, and now the ring will become electron deficient. Only 4 electrons will be here and will form bond with the electrophile. See, as we know, in benzene, at each carbon there is 1 hydrogen. So 1 hydrogen is here, and this acetylation ion will form bond with the ring. Is it clear? In order to write the reaction over the paper, I'm taking the help of one of the resonating structure proposed by the Kekulé for benzene. See, this one is benzene, and it is having a 6 electrons. Now the electrophile approaches the ring, and now by making the use of these 2 electrons, the ring will form bond with the electrophile. Now at the ring only 4 electrons will left here. Now one of the carbon will form bond with the electrophile. The adjacent carbon will become electron deficient, because in this bond 1 electron is of this carbon, other of this. As both the electrons has formed bond with the carbon, 1 carbon, so another carbon will become electron deficient. Now this type of carbocation will form as an intermediate. Now this carbocation remains stabilized by the presence of the resonance. See what happens? In order to compensate the deficiency of the electron or this carbon, these adjacent electrons shifted here, and we obtain then another resonating structures. As these two electrons shifted here, double bond will form. This carbon will become electron deficient, and here it is. See, double bond O. Now, to compensate the positive charge or deficiency of this carbon, these electrons shifted here. We'll get one more resonating structure. See, double bond. As these two electrons shifted here, double bond will form. This carbon will become electron deficient, and here there is an hydrogen, and at this place there is this one. Actual structure is none of these. Actual structure lies in between all these. In this actual structure, the positive charge rotates over the ring, and at the ring there is one hydrogen and one the electrophile. This structure is resonance hybrid. We may call it also a sigma complex. So in the second step, sigma complex or resonance hybrid is formed. This one is the actual structure. See, remember that these resonating structures does not have any existence. Now, what actually happens here? Finally, in order to compensate the deficiency of the ring, the hydrogen which has to be replaced donate its electron pair to the ring and sets free as proton, and thereafter the deficiency of cloud of the ring is compensated, and the electrophile forms bond with the ring. See, so this step can be expressed as, see, in step 3, this hybrid, resonance hybrid, will lose a proton. Loss of proton occurs. Now what happens here? Here there was a hybrid, resonance hybrid. And now this AlCl4 or AlCl3.Cl minus abstracts this hydrogen as a proton, and now this proton combines to the Cl minus forming HCl, and this anhydrous AlCl3 will set free, and now the deficiency of the ring will be compensated. Here there's the double bond now, and we will get our acyl benzene, or we may get the aromatic ketone. See, remember here, in all these 3 steps, this one, second step, it is slow step, and therefore is rate determining. Here, this one, third step is fast. Is it clear?